So this one, the assignment related to circular motion. First 19 questions are recorded, so we'll do from 20 onwards. In this question, International Space Station is in orbit at a height of 400 kilometer above the Earth's surface. The ISS completes 15.5 orbits in 24 hours. Calculate the angular velocity in radian per second. So angular velocity means omega. There are different formulas to work out the omega. Like it is 2 pi divided by f is 2 pi f is there, or 2 pi divided by t. The main formula of omega is equals to theta divided by t. So first we write a formula that we have, and whenever you're solving a question, always write a formula. So omega is a change in angle divided by the time interval. They mention here it is completing 15.5 orbits in 24 hours, but we need in a radian per second. Like 15.5 revolution is there, so we have to convert that into radian. So 15.5 like one revolution is 2 pi radian, so we 15.5. So the total radian will be multiplied by 2 pi. So 15.5 multiplied by 2 pi. And then the time 24 hours, but we need radian per second. So first hours we have to convert into minutes. So we multiply by 60. And then the minutes we have to convert into seconds. So we multiply by 60. But time is in denominator. That's why we did this in denominator. You can separately work out the angular displacement and then the time, and then divide them, you'll get the answer. So this will be 1.1 into 10 to the power minus 3, and the unit will be radian per second. A student suggests that International Space Station is traveling at a constant speed. So according to Newton's law, there will be no resultant force acting on it. So if something is moving at a constant speed according to Newton's law, there should be no resultant force. Look, even though its speed might be constant, but its velocity is continuously changing. And why the velocity is changing? Because it is continuously changing the direction. So even though, because speed is a scalar, where velocity is a vector quantity, so we can say that the speed is constant, but the velocity is changing as the direction is changing. So, and because there is a change in velocity, so this must be accelerating. And whenever there's an acceleration, there must be a force. And that force in this case is acting toward the center, or the centripetal force is there. So how we write the answer? We'll mention the speed is constant, but the velocity is changing. So whenever object is moving in a circular path, it will always accelerate. So speed is constant, but the velocity is changing due to direction, or due to change in direction. So it is accelerating, and as a result, it will experience resultant force, because whenever object accelerate, it will experience a resultant force which is directed towards the center. Calculate the magnitude of a centripetal acceleration. The mass of International Space Station is given, and the radius of the Earth is also given. And it is 400 kilometer above the Earth. So Earth is there, and say this is International Space Station, which is 400 kilometer, and this one is the radius of the Earth, which is 6,400 kilometer. The mass of the International Space Station is also given. We need the magnitude of a centripetal force. So centripetal force is m r omega square. We can use that, or it can be mv square over r. But we don't know, the speed is not given, so we can use this formula. Angular speed we already worked out in the previous part. So we just have to substitute. But the important, you have to take a distance from the center, and the SI unit of a distance is meters. So you have to convert into meters. So mass of a space station, 4.19 into 10 to the power 5 multiplied by the radius, which will be 6,400 kilometer, means 10 power 3 plus 400 kilometers, so 400 to 10 power 3. We will add them. And multiplied by angular speed, which we already worked out, 1.1 into 10 power minus 3. 1.1. So this will give us 3.6 exponent 6. So this will be 3.6 into 10 power 6, and the unit will be Newton. So important thing is the unit conversion and taking the total distance, as we always take the total distance from the center. So whenever object move in a circular path, take a distance from the center if you want a centripetal force. So this was a circular motion.